Now problem number 2. A string is stretched and fastened to 2 points L x equal to 0 and x is equal to L apart. Motion is started by displacing the string into the form y is equal to y naught sine n pi x by L, from which it is released at a time t equal to 0. Show that the displacement of any point at a distance x from one end at time t is given by y of x comma t is equal to y naught sine pi x by L into cos pi at by L. Solution. The explanation is the same as in the previous problem. Same sentences, only the change in this problem is you observe that y is equal to y naught sine n pi x by L. In the previous problem, the initial displacement is k into Lx minus x square. Instead of k into Lx minus x square, here it is given that y naught sine n pi x by L. This is only the difference for the previous problem and problem number 2. So this is only the difference between previous problem number 1 and problem number 2. Remaining as it is same. Now write down the one-dimensional wave equation. And also one more change, you observe that in the solution here A instead of C, here he used A. So we will also take A instead of C in the one-dimensional wave equation. The one-dimensional wave equation is dou square y by dou t square equal to a square into dou square y by dou x square. As explained in the previous one, from the given problem, we get the following initial and boundary conditions. We get the following conditions. That means initial and boundary conditions. Now, condition number 1 is at one of the boundary, that is 0, at any time t, displacement is 0. For all t greater than 0. Condition number 2, at another endpoint L, the displacement is 0 at any time t, equal to 0 for all t greater than 0. At both the end points, the displacement is 0. There is no displacement at both the ends. Condition 3, initial velocity in the string is 0. Dou by dou t of y of x comma 0 equal to 0 for all 0 less than or equal to x less than or equal to L, since initial velocity is 0 in the string. Condition number 4, initial displacement in the string y of x comma 0 is equal to, it is given that y naught sine n pi x by L for all 0 less than or equal to x less than or equal to L. This is condition number 4. Now, the correct solution which satisfies our conditions, initial and boundary conditions, the correct solution of one-dimensional wave equation which satisfies our conditions is y of x comma t is equal to c1 cos px plus c2 sin px into c3 cos cpt, but here we used a instead of c as in the given problem, so we use apt c4 sin apt. So instead of c in the previous problem, here we are using a. Say this is equation number 1. As in the previous problem, here also condition number 1, condition number 2, condition number 3 are same, similar. So therefore, the solution is also same till the equation number 5 as in the solution of previous problem. So here also we will write the same solution till equation number 5 with a simple slight modification, that is instead of C, here you just write A. Since the solution is same till the equation number 5 with a slight modification A instead of C in the previous solution, you can copy the same solution from problem number 1 with the changing A instead of C. Now I will continue the solution from equation number 5 onwards. The most general solution equation 4 can be written as y of x comma t is equal to sigma n is equal to 1 to infinity bn sin n pi x by L into cos n pi ct by L is in the previous problem, but here instead of C we are using A. n pi at by L. Say this is equation number 5. My dear students, don't forget to copy the solution from the previous problem with instead of C replacing A. In between 1 and 5, you should copy the same solution from the previous problem with the change A instead of C. Don't forget it. Now applying condition number 4 in equation number 5. That means put t equal to 0 in equation 5 and then substitute y of x comma 0 is equal to y naught sin n pi x by L. Now applying the condition 4 in equation 5. We get put t equal to 0 here. Y of x comma 0 equal to sigma n is equal to 1 to infinity bn sin n pi x by L into cos of n pi 8 into 0 by L, that is cos of 0. Therefore y of x comma 0 is equal to y naught sin n pi x by L. Y naught sin n pi x by L equal to sigma n is equal to 1 to infinity bn sin n pi x by L, since cos 0 is equal to 1. Cos 0 is equal to 1. Now here no need to expand this in a half range Fourier series to find Bn, because in the left hand side only single term is there, y naught sin n by x by L. So without using the half range Fourier sine series as in the previous solution, here we just find the value of b1, b2 and so on bn by equating the coefficients of sine terms on both sides. You see here this can be written as y naught sine n pi x by L is equal to, put n equal to 1, b1 sine 1 pi by L sine 1 pi by L into x. You make a note that in the problem initial displacement is y is equal to y naught sine pi x by L, not n pi x by L. Sorry, this is pi x by L. In the condition number 4 also you change sine pi x by L. there is no n. Here also sin pi x by l. Now here plus put n equal to 2 b2 sin 2 pi x by l plus put n equal to 3 b3 sin 3 pi x by l plus and so on up to infinite. Now equating the coefficients of sine on both sides. Now equating the coefficients of sine terms on both sides. We get here b1 is equal to y naught and b2 is equal to coefficient of sine 2 by x by l in the right hand side, but in the left hand side there is no term involving sine 2 pi x by l, so 0. b3 is the coefficient of sine 3 pi x by l in the right hand side, but in the left hand side there is no term involving sine 3 pi x by l, therefore that is a coefficient is a 0 and so on. bn is equal to 0 and so on, all the terms being 0. Therefore substituting these values in equation number 5, we get the required solution. Substituting these values in equation 5, since the most general solution is in the equation number 5, we get except b1 all the b2 b3 b4 and so on being zeros. Therefore y of x comma t is equal to b1, that is y naught sine pi x for n equal to 1 only pi x by l into cos, since n equal to 1, pi at by l. b2 b3 and so on all are being zeros, therefore 0 sin 2 pi x by l cos 2 pi at by l plus 0 sin 3 pi x by l cos 3 pi at by l plus and so on. Those values becomes a 0. So therefore we are not writing all the values since all are being zeros. Therefore we are just writing only the term involving b1 and its value is equal to y naught. Therefore y of x comma t is equal to y naught sin pi x by l cos pi at by l. This is our required solution. So in the given problem, it is asked that show that the displacement of any point at a distance x from one end point at a time t is given by y naught sin pi x by l cos pi at by l. So we got this solution. So this is our required solution. This completes the solution of the problem number